Okay. Alright, it's 5:30 now. I guess we should start. Welcome everyone to the MVC or MVVM architecture and software communications. So the main goal of this workshop is to have an understanding of software architecture and design patterns, and also to use that design pattern to understand how certain pieces of a software, or in our case, web application, communicate with each other. So this is the outline for this workshop. So firstly, what is MVC-MVVM architecture? Why is it important? How do front ends communicate with the backends? And to finish off the workshop, we're going to have a demo. Okay. So firstly, what is the MVC or MVVM architecture? So I guess to understand architecture first is that architecture is basically how a software is divided into different pieces of technology, and also how those particular technology embody a certain role in the entire application. So MVC or MVVM is one of a software design pattern in which we really have three main parts. Firstly, let's take a look at MVC. With MVC, we're going to have three parts: the model, the view, and the controller. The model's role is for data representation layer. It's basically how an app communicates to a database. So it's like this, how the model communicates with the database. Actually, let's run through this workflow first. So if a user interacts with the browser have some sort of routing mechanism. So it's that URL. And that for a particular URL, it goes to a certain controller. A controller basically does some sort of processing of HTTP requests, and also it relays requests from the application and also to the user. So in this case, the controller gets some data from the model, and then the model communicates with the database, either with raw SQLs that you write, or you use an object relational model. Furthermore, once the interaction between the model and the database ends, it gets the data to the controller. The controller relays that data to the view. The view is basically the interface representation, and it's with HTML, CSS, and JavaScript. So this is a classic example of actually what's called a server-side rendered, wherein the server application relays the data towards the view, generates the HTML, CSS, and JavaScript, and then sends these details back to the browser for the user to see. So I hope that the MVC is clear. MVVM is kind of a variant of MVC, except it it modifies something a little bit differently, especially the view, and also it removes the controller. So it adds this one layer and also removes controller. The view model is basically a data binding relays. It's similar to a controller wherein it relays any type of HTTP request, but I'll show you in a second into how it actually looks like. So one thing that I'd like to acknowledge is the fact that this MVC or MVVM architecture, this particular slide, may not be correct. Because if you search the Google with MVC or MVVM, you're going to see a lot of conflicting details. So I'd just like to acknowledge that this portion of the slide is explained to make front-end and back-end integration easier to explain. Okay? So let's put MVC and MVVM architecture into actual practice. So let's take a look at, for example, with the Django REST framework. Currently, it's not really that visible as to what certain pieces of technology operates at what. But I have more examples that comes up. So let's take a look at this. The browser goes to the route. It goes to what's called the Django REST framework. Django has what's called a Django ORM, communicates with the database, then sends back the data towards the controller. The controller relays the correct template engine. So Django has a template engine for which to render the data, and then sends back here, and then HTML, CSS, and JavaScript is sent back to the browser. Now let's take a look at an MVVM architecture. So this time we're going to be using Django and React. So let's go with React. So React represents the view, whenever you have user interactions, like for example, you have button clicks, then you have an event. The event dispatches something to the Redux. So just to say, Django REST Framework and Redux are different pieces of the stack. Django REST Framework is part of the backend, but Redux is part of the frontend. So the purpose of Redux here, for anybody that doesn't know what Redux is basically what's called a store management. Its main purpose is to relay data, mainly on, it binds the data to the interface. Means that every time the data changes, the view or the interface changes. So let's take a look at an example. What if we have a to-do event? I added more to-dos. The to-do goes to Redux. Redux sends a signal or HTTP request to the Django REST framework, and then updates the model, and then this Django REST framework is notified whether the change has been updated correctly or unsuccessfully. So it gets notified, then relays that change to Redux. Where Redux, because of the data binding, will change the interface. So I hope in some extent that makes sense in terms of when we have events, it updates database, but at the same time, it also updates the interface. So in contrast to this one, this will probably be what you call server-side rendered approach, which means that every time you have an interaction, the page refresh. Like for example, I submit a form, um, it's gonna get routed to this one, and then this one will refresh. This one, on the other hand, is that whenever you have some data interaction or updating of data in the model, you don't have refresh in the interface, but the interface gets re-rendered with the new data. So I think the part of Django is, it's hard to explain because Django as a whole does a lot of things as a framework. So let's take a look at smaller frameworks. So this is a little bit much more understandable. Now let's replace Django with the classic Flask. So Flask, as you can see here at the left-hand side, there's really three main parts from the when Django was replaced. There's three parts that was involved. You have Flask, wherein you could write controllers and basically HTTP request relays, and then you use SQL Alchemy typically for when you do database or model interaction. You can change SQL Alchemy to whatever ORM there is, or actually you can even replace it with just raw SQL if need be. And then once you have that data, it relays that to Jinja. Jinja is like a templating engine similar to Django templater. Now let's take a look at the MVVM architecture on the other hand. As you can see, Jinja disappeared because the backend no longer needs to render HTML, CSS, and JavaScript. It just sends data, which I'll show you in the next slide how it sends data. Here's another example. Now we replace Flask with Node.js and Express. So as you can see, the controller, Node.js and Express. And then you change the previous one, SQL Alchemy, to SQLize. And then the Jinja templating engine with what's called EJS, or Embedded JavaScript. And this is also the equivalent for the MVVM architecture. So I guess that brings us to, why is software architecture important? So architecture shows how an entire software works in a high level. So like, how does it function? It's important for the cases wherein you're trying to maintain software and also extend the software. So by looking at architecture diagrams, you know in some extent how a certain software is limited. So what can you do about it? So that an understanding of software architecture makes it easier to replace certain pieces and parts of that technology stack. So you also have what's called separation of concerns, wherein we try to split the backend and the front end based on the purposes in the software design pattern. Nextly is choosing different pieces of the stack. So as you've seen in the previous slide is the fact that whenever we change a particular technology, certain pieces of the stack will also change. Like for example, when we change Django to Flask, the templating engine changes, the model changes, and also the controller changes. So yeah, over time, as you go deeper in the software field, you're going to see a much more complex architecture. So I've attached a couple of architectural diagrams there that are they still follow MVC or MVVM in a certain extent, but they're like a variant. I just like to acknowledge as well is that there's a lot of different software architecture, but in terms of the web, usually you have MVC and MVVM, and all the other architecture are variants of it. Okay. Now it brings us to the next part of our workshop. So now that you understand, in some extent, the software design patterns and how we split up certain pieces, like this one is front end, this one is back end. So now let's try to understand how do front ends, or in our case, firstly, is how do browsers communicate with the backend? So it communicates via what's called HTTPS requests. So firstly, you have a user interface. It goes to a certain URL. So let's say it goes to www.todoapp.com. So it goes to the cloud and then reaches to the server. The server will be connected to the database, and then it's gonna get data from there. So depending on whether you're generating interface from the server or you're generating interface from the front end, the data that you send back to the interface will depend. So it could either be with HTML, CSS, JavaScript, or with what's called JSON or XML. Furthermore, those HTTP requests will match what's called an HTTP verb, and that's dependent on what action are we trying to do. So, uh, in our case, what if the user firstly it goes to the todoapp.com, it does a GET request because it tries to retrieve all the to-dos in that particular server or database. And then what if the user fills up the form and submits a to-do application? So now it sends what's called a post request. A post request is to create. Uh, it's a create action towards a database. So there's more aside from get and post. There's also put, patch, and delete. So as you can see, in some extent, this actually matches the CRUD operations. So if you're familiar with the CRUD operations, they're basically the type of operations that you could do in a database. So in certain extent, the CRUD functionalities or CRUD operations maps towards what's called the HTTP verbs. There's actually two parts of the update. There's put and patch. Put does an up. It basically replaces the entire particular entry, and patches kind of like puts more fields. As you can see also as well here in a typical pattern of how backends are created, they're typically going to have two get route patterns. So we have get and then users. This one in particular, it retrieves all users. Next one is get, and then we have a user and then the ID as the next parameter. It retrieves that particular user. So that's similar as well for the update a user because you need a particular user to update, and for the delete as well. So I hope that part makes sense in terms of the HTTP verbs and also the CRUD operations. Which brings us to the next one, server-side rendering. So again, what if the user goes to the server to do app.com? So what ends up happening is that it's going to get all the to-do applications or to-do app details, and then it renders the HTML, CSS, and JavaScript, and then sends back what's called a dynamically generated HTML because you've generated the HTML in the server, and now it's getting rendered here in the browser or front end or user interface. So, and that's called server-side rendering. Next one, we have what's called client-side rendering. Wherein, what if we don't have refresh? So let's go back to this one. So what if, yeah, I am in the todoapp.com. I submitted a form. My request is what's called a post request because I created a new one, and then it generates new HTML and CSS JavaScript for me, and sends back to the browser. So as you can see, actually, in some extent, this is repetitive in nature. Like for example, the website uses the same CSS majority of the time. The HTML, well, there are actually repetitions. What if we have the headers and we have the footers? Those particular pieces don't necessarily change a lot. So, which leads us to the client-side rendering. So, what if we just send a blank HTML with JavaScript, and using the power of JavaScript as a programming language that can interact with the HTML document object model, technically we can generate HTML from the browser itself. So the idea of client-side rendering is that you send a request to the server sends a blank HTML with JavaScript, and then JavaScript sends back another request depending on what resource you need. So if you need to-do app, to-do list, you're going to get what's called a JSON or XML. And that brings us to AJAX. AJAX is what's called the asynchronous JavaScript and XML. And I'm not going to explain XML that much, but think about it like it's a markup language that is just used to represent data. In this particular day and age, XML is not that dominant. It's usually called JSON. JSON is what's called a JavaScript object notation, and it typically looks like this. So you have a data representation, you have particular fields, and then you have data. And then with client-side rendering, we read this data. So, and then once reading the data, we generate HTML based on the data that we've gathered. I'd just like to point out that JSONs are strings, but you have to serialize JSON to become an object. Even though the name is called JavaScript Object Notation, it's a string, just needs serializing to become object. So any questions before we go to our demo? Okay, I guess, yep. Oh, I'm not, I'm not actually sure. I have 1080p. Oh, I can't do 1080p. I'm maximum 720. Yeah. Does the slide still look a little bit grainy? Oh man. Oh. So are there any questions about the workshops for now before we go to the demo? So the demo link is right here. So uh, I didn't really have a lot of time for preparations. That's why I just forked somebody else's to-do app and refactored a little bit, and also added a little bit of documentations on what's important and also how it relates to our workshop today. Okay, so I guess let's start with the workshop demo. So this is what the to-do application that I forked and also refactored look like. So you could add more to-dos. I submit the thing. As you can see, it adds things here without refreshing. Okay, hang on a sec. Screen, did you say? There you go. You guys see. Oh, let's. Yeah, there's the better text readability. Now let's go to costume. Is that better? Oh man. Oh, don't worry. This is fairly intuitive. This is just a to-do app. So yeah, add more things there. I submit, and as you can see, it refreshes my interface without actually it re-renders my interface without a page refresh. So, and also I can edit. I can edit the to-do application. I can edit or remove to-dos. I can also cross out things. My backend looks like this. So that's this. Actually, API. So this is a React and Django to-do application. So I have a couple of routes. So API, I have API task list. And then I have certain details about my to-dos. So whenever I add things here, I refresh this particular page. It will show me what my JSON package looks like. This is what you'll call JSON, JavaScript Object Notation. And let's go through the code, the important bits of the code for that one. So there's actually three main important codes or files right there. Okay, let's zoom in. Can you see it now? Oh, man. Alright, that works now. Okay. So there's really three main parts of the app that actually four main parts of the app that is important. Firstly, we have the front end or the app.js. This contains the front end that we have, and it represents the view. It also contains part of integration logic, which is you'll say a view model. And then we have the API models.py. It contains the database logic and also the model. The URLs.py and views.py will contain the endpoint and also the routing logic of the views for the front end. That's called the view model. So let's go first with the simple one, the models.py, because this is handled by the ORM. So I go to my backend logic, and I have models.py. So as you can see, there's only two fields that I am concerned about for this particular endpoint. We have the title, and also is it completed. So if you take a look at back to our endpoint, there's only really a couple of pieces: the title and the completed. The ID is a primary key that's auto-generated by the SQL database. So I hope that's the model makes sense. Next part is the URLs. The URLs actually just determine at what particular path do I give data or interaction for the backend. So I have a couple of things here. I have the list as a particular detail, the create endpoint, update, and delete. So let's go to views.py. So this is my view model for that particular endpoint. So this is the listing. So this is fairly straightforward. So I have the task. The task is an import from the model. and then I just basically query all and then order by the ID, and then the serializer just makes it look nicer in terms of a JSON format, and then I respond with that. And that's almost similar to all the other endpoints. We have the detail, except objects all. It gets that particular primary key that's defined by the URL. So let's say, for example, I do API task detail, and then I said 55 because it's this one. It will get me the detail of that particular to-do details. And then I think that's also similar for all the other view models. Task create just takes a look at whether the request data is valid, and then saves it as a model and updates and delete. I think that's for the models, and also view model for that part of the backend. Now let's take a look at the view model and also view in the front end. So there's only really one file that's important here, app.js. So firstly, let's take a look at the view model. So I'll just zoom out in a bit because this is harder to show. But this basically is the HTML, or what you'll call JSX, JavaScript embedded in XML kind of thing. It's like a HTML, but it has some dynamic attributes. So like, for example, whenever the form is submitted, this function is called upon. So this basically represents the rendering or the view logic, and it's binded by our what's called the state. This is basically something like, if this data changes, the front end changes. Okay, so let's take a look at a little bit of the integration logic. So we have this one. This is a code that executes on load. The exact syntax, you don't have to know it at this point. I'll cover that in the React workshop. But essentially, we have this one, the read operation. It does a fetch on our URL. So in this case, it fetches details on the task list. So this one, API task list. The backend API URL, just to show you, it's this one. It's a constant that has this particular IP address and also /API. Yep. And then after awaiting for the details that came from the backend, I serialize the JSON so that it becomes an object. And then I set my to-do list to an array of objects. So it's the same case of this one, except JSON, as I've said, it's a string. It just needs to be serialized so that it becomes an array or it becomes an object. So that's that one. Handle change is just a form handler. So whenever I change details about my to-do app, so this one, it changes the state. So that's just for form handling collection, but this is for the create and edit operation. Let's explain that in a little bit much more detail. So as I've said, the handle submit is binded with the form. So whenever I'm submitting, there's an event. I do an event.prevent default so that it prevents the page reload. Don't mind this particular bit. It's just some cybersecurity part of Django. So now let's get into a little bit of detail here. So my URL, depending on whether I'm editing or I am not editing, my endpoint is either task create or task update for the active item. So after that, after this particular bit, that you know what URL to send it to, I do a fetch request. So I think, just to clarify, fetch is what's called a function that invokes an HTTP request. It's not necessarily just a fetch. It sends an HTTP request. Yep. 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 Just give me 3 minutes and I'll just. Yep. So it sends an HTTP request to a particular URL, and you need to specify the method. So like for when I said with the slides, wherein we have different HTTP verbs. So get, post, put, get, delete. So in this case, I'm sending a method for post. And this method should actually corresponds to the view backend. So whatever I specify here. And just to finish it up, these HTTP verbs are just standards. And standard means that they're not necessarily ingrained upon, but for best practices, you follow these standards. I think that wraps up majority of the front end. There's only one bit that's left to cover, which is what happens after I perform the request. Currently, I just refresh the task. Basically, it gets it's take a look at the endpoint for all the tasks, and refreshes my state. But it's not the best way to do it. Usually, the best way to do it is that you use the return data of the response and then appends that to your state. Okay, I think that ends this workshop. Okay, I'll end this recording now.